Hi everyone, this is the second part of the video. If you haven't watched the first portion, please watch that first. Okay, so we were studying summation of arithmetic sequence and summation of geometric sequence. So continuation from previous video. Compute each sum below. If applicable, write your answer as a fraction. So we're looking at the B. It has a sigma notation. K equal to 1 through 9, 1/3 to the k power. So if you are familiar with this, you should notice, this is a geometric sequence right away because you have a kth power. I'm trying to tell you, you need to know if this is arithmetic sequence or geometric sequence first. And if you can tell, it is geometric sequence, very good. If you have no idea, I don't know why you're saying this is a geometric sequence, why not arithmetic sequence, then you might go through this process. So sigma notation means you plug it in k value as 1, plug it in 1 to this expression. So if you do plug it in 1 here, 1/3 to the 1 power, which is just 1/3. Then next value after 1 is 2. Plug it in 2 to this expression. 1/3 to the second power means 1/3 times 1/3, which becomes 1/9. Next number after 2 will be 3. You plug it in 3. 1/3 to the third power. 1/3 times 1/3 times 1/3. 3 times 3 times 3 is what? 27? 1/27. You get the idea. Plug it in 4. 5, 6, 7. You might say, well, when do we stop? Right here. Terminating number is 9. You plug it in all the way up to 9. So last number, plug it in, will 9. 1/3 to the 9th power, whatever that is. Well, let's see. Calculator can handle that number. 1/3. 1/3 to the power of 9. Yes, he can handle it. That is 1/19683 is the last number. Sigma means add them all. That's what sigma means. You have a bunch of number between, add all of them. Okay, then you can tell what's going on, what kind of sequence is that. Well, if you looked at here, you could tell first element was 1/3, second element is 1/3 to the second power, which means 1/3 times 1/3. So you should have noticed right then, we multiply by 1/3 here. That's why it's the second power. Third power means we multiply by 1/3 again. So that's one way to look at, this is a geometric sequence. So geometric sequence has two different formulas. One with a summation formula when the sequence is finite, meaning it ends. Infinite geometric series has different formula. When the sequence keeps going forever, it doesn't stop, then there's a different formula. There is end to it because we are only adding up to the 9th term. First, second, all the way up to 9th term. It ends. So we get to use this formula. S of n equal to a sub 1 parenthesis 1 minus r to the n power all over 1 minus r. N is last term. They gave it to you. Add all the way up to 9th term. What does that mean? Value of n equal to 9. A sub 1 is the first term. Do we know first term? Yes. If you plug in k equal to 1 here, that becomes the first term, which is 1/3. 1 minus r was 1/3. R is 1/3. Please parenthesize. Power of n is 9. All over 1 minus 1/3. Please parenthesize. All you have to do is plug that into the calculator. Again, if your calculator does not have a fraction key, You want to parenthesize the entire numerator, you want to parenthesize the entire denominator when you type into the calculator. So, parenthesis 1/3, parenthesis 1 minus, parenthesis 1/3, power of 9, close, divide by parenthesis 1 minus, parenthesis 1/3, close. Okay, I got a fraction which is 9841 all over 19683 is my final answer. And that is yes, that is the correct answer. Okay, next question. Next question I want to deal with here. Compute each sum below. Give exact values, not decimal approximations. If the sum does not exist, click on no sum. Okay, let's look at the first example. 4 plus 4 parenthesis 4 plus 4 parenthesis 3 plus 4 parenthesis 3 to the second power plus dot dot dot. So take a look at this example. First question. Is this arithmetic sequence or geometric sequence? So what happened from first term to second term? First term is 4. Second term is what? 4 times 3. So what happened from here to here? They times 3. They multiply by that's what happened. Multiply by 3. Well, from second term to third term, look at the power of 3. 3 has a first power, 3 has a second power, which means we multiply by 3 one more time. So from second to third, what happened? They multiply by 3 again. What kind of sequence is that? Geometric sequence. Geometric sequence. We are adding them, so it's a geometric series. Summation of geometric sequence means geometric series. So geometric series has two different formulas. One is finite. It terminates. It has end to it. The other one is infinite geometric sum. Infinite geometric sum. If the sequence does not stop, it keeps going forever, we have different formula. Okay, there's a catch. If absolute value of r is less than 1, we do have a formula. What if absolute value of r is not less than 1? There's no sum. Answer should be no sum. Okay, now we do know this is a geometric sequence or geometric series, and in the next question should be, is it terminating or is it infinite? Do you see plus dot dot dot? There's no other term at the end. Dot 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 means it's gonna continue forever, meaning this is infinite geometric series. So you get to use this formula. Okay, here's a catch. You have to check the condition. If this condition is satisfied, you get to use this formula. You're done. What if this condition is not satisfied? No sum. R value, we just calculated R value. R value was what? R value was 3. And condition says absolute value of R has to be less than 1. Absolute value of R is 3. Absolute value of 3 is 3. So question, is that less than 1? Is 3 less than 1? What does that mean? You cannot apply this formula. Your answer should be no sum. No sum. Done. You cannot get the sum here. Why? Number is getting bigger and bigger and bigger. The number itself is approaching to infinity. When you add them, that's gonna be more infinity. Well, technically, it doesn't make any sense. More infinity, less infinity. Infinity is infinity. But when you add them, the number is not getting closer to any. It's just gonna keep growing. So. Okay, this question here. This question is the next question, and let's take a look at it. So if you look at it, j equal to 1 through infinity, what does that mean? You're going to plug in j equal to 1 here, get the value. Plug in j equal to 2, get the value. J equal to 3, get the value. Get the value, and at the end, you're just adding them all. But when do we stop to plug it in value of j? You never stops. 1, 2, 3, 4, plug it in, keep plugging it in, all until what? Infinity means you keep plugging it in forever. So, again, noticing j being an exponent, you should recognize, this is geometric sequence, which becomes geometric series. But if you don't understand why that's a geometric sequence, you may have to plug it in some j values. But since we have an exponent here as a j, then you know that is a geometric sequence. So I'm going to plug it in j equal to 1. Plug it in j equal to 1, you got minus 3, 7 to the 1 power. So if you evaluate it, that will become minus 15 sevenths will be your first element. If you plug in next j value, which is 2, plug it in 5, minus 37 to the second power. So you get to think, if you want to get that value, that should be what? 949? And 9 times 5, 45, 49. Then next element after j of 2 is going to be 3. Plug in 3, so 5 times 3 to the 7th, third power here. So if you couldn't tell whether it's geometry or arithmetic there, then once you plug it in 1, 2, 3, 4 value of j's, you get to see, what happened here to here? We multiply by minus 37. What happened from here to here? We multiply by minus 37. So you get to see, it is a geometric sequence. Then what? Do you remember geometric sequence has two different formulas? One is finite, one is infinite. Do you see the terminating index is infinity? That means it's an infinite sum. Meaning you get to use this formula. Let's check the condition. What's the value of r? Well, value of r is minus 37th. R is minus 37th. So to check the condition, you need to get absolute value of r. If you take absolute value of minus 37th, which is 37th, question is it 37th less than 1? Yeah, 37th in decimal, it's like less than 0.5. If you put that into the calculator, 37th is less than 1? Yes, it is. What does that have to do anything? Well, we get to use this formula. So S equal to a sub 1 all over 1 minus r. So a sub 1 is the first element. When you plug it in 1 for this expression, we got the first element was minus 15/7. Minus 15/7. So we got first element minus 15/7. 1 minus over 1 minus r. R was minus 37th. And that would be format. If calculator is allowed, you just type into the calculator. Make sure you put parentheses on the denominator because that's not monomial. 1, 2 terms here, then you have to parenthesize. Numerator, it doesn't matter. You can put the parentheses on numerator as well, but this time the numerator parenthesis is not necessary. So if you have a calculator available, just put that into the calculator, done. If your calculator is not available and you have to do by hand, then you might have to do by hand. Minus minus, double minus becomes a positive. 1 is exactly the same as 7 over 7 because you want them to have a fraction with the same denominator. So 1 is the same as 7 over 7. Then you get to add them. Minus 15 over 7. 7 plus 3 is what? 10/7. So fraction numerator over denominator is same as numerator divided by denominator. So this is same as minus 15/7 divided by 10/7. Divided by fraction is the same as multiplied by reciprocal. 7 cancels out. Cancel out 5, 3, 5, 2, minus 3/2 is the final answer. Okay, let me show you next example. So if you look at the sequence here, minus 2/3 to the second power, third power, you should know, this is a geometric sequence. You're multiplying by minus 2/3. You're multiplying by minus 2/3. What does that mean? This is geometric sequence. R is minus 2/3. And you see plus ... meaning it does not terminate. What does that mean? You have to use infinite sum formula for geometric sequence. Check the condition. Absolute value of R less than 1. Is that true? If you look at the R is minus 2/3, take absolute value of that becomes 2/3. You're questioning 2/3 less than 1. True or false? True. 2 is like 0.6666 as a decimal. It is less than 1. What does that mean? We get to use this formula. So S equal to a sub 1 all over 1 minus R. A sub 1 is the first term, which is minus 2/3. 1 minus R. R is minus 2/3. Make sure you put parentheses. So, if you have a calculator available, make sure you put another parenthesis, put that into the calculator, and you're done. If you don't have a calculator, you have to do by hand. Double minus becomes a positive. Minus 2/3. 1 you want to express as a fraction with the same denominator. 1 is 3 over 3. Then you can add them 5/3. Same process. Numerator over denominator is the same as numerator divided by denominator. Divide by denominator is the same as multiply by reciprocal. Cancel. Minus 2/5 is your final answer. Okay, last question. If you look at it, the minus 4 to the k power, and sigma of k equal to 1 through infinity. So if you are familiar with this, you should recognize, this is a geometric sequence right away. If that doesn't make much sense to you, plug it in. K equal to 1, k equal to 2, plug it in. K equal to 3, plug it in. Then take a look at it. What's going on? First power, second power, what do we do to minus 4 to the first power to make minus 4 to the second power. We multiply by minus 4. Multiply by minus 4. That's why the power went up. We multiply by minus 4. So you should know, this is a geometric sequence. Adding it, so it's a geometric series. R value is minus 4. Is it terminating? No, look at the index, it's infinite. So infinite, we have to use this formula. Before that, check the condition. Absolute value of R less than 1. R is minus 4. Absolute value of minus 4 is 4. Is 4 less than 1? What does that mean? No sum. No sum. That is your answer. Okay, you should be ready for Alex assignment 11. I will see you guys for next week.